Hello, everyone, and welcome back from the break. We'll be resuming in a couple of minutes. Our speaker has a bit of technical issues, so we're going to be waiting for somebody to join as well and resuming in 5. I can see more people have joined now. For those that haven't heard, our speaker is having a bit of technical issues and we'll be resuming in a couple of minutes. Thank you. Thank you, everybody, for making it back from the break. Our speaker is unfortunately unable to make it, so if you would consider it, maybe you join stream 1 or 3 instead. And thank you so much for taking the time to join us here in stream 2.
Hello, everyone.
Hello, Krishnendu.
Hey, hi. I'm sorry, I was having some problem joining the Zoom session. So,
Thank you for taking the time to make it. Unfortunately, some people have left to the other stream, so we are currently handling the technical bits.
I'm sorry,
If you
I
could,
don't know. It was, uh, it had some problem. I could not join in, so I asked Marija to send me the link over LinkedIn right now, and then it could. I do not know what was happening on the calendar link.
all right, I'm happy you could make it after all. So thank you so much for joining us today.
Thank you so much. So we have a few people joining in. So should we wait for other people or should we just start right now?
I think it would be best to give it a few more minutes, just
Oh,
a
okay.
minute or two, so everyone can maybe join back in.
Oh, okay.
I will be making the introductions for everybody who has come back from the break. Everybody, welcome to the stage, Krishnendu Dasgupta, who is founder at Axon Vertex AI, who will be sharing his knowledge on the topic of building responsible AI agents in decentralized environments using open source. Again, thank you so much for taking the time to be with us today.
Thank you so much. And very glad to meet all of you. I know that I'm not able to see a lot of people. I just can see the name, Rudolph, Julian, Fish. I was thinking that would be more like people can communicate kind of a session? Is it something like that, or is it more like just like a webinar that we are looking at? Because if it is like a session, then I would prefer to have people interact more, right, at the Zoom call.
I,
So, what is the format of this? This is more like a complete webinar kind of a model.
the last one was a webinar, but hopefully during the few minutes that we are waiting for people to join in, I can also enable everybody's microphones so that it's more interactive.
Oh, perfect. Okay, so I'll then quickly start. Like I've got like a power pack thing for everything that I've created. So and not take much time. And let's start from there. Okay, let me share my screen a little bit quickly. Okay, yeah. Let's let you know. So, is this one? So I hope everybody can see my screen. Somebody can raise, like, just give something or drop a message in the chat. At least I can know that people are able to see my screen.
We can see a screen.
Oh, perfect, great. Okay, so uh, let me know if you are able to see right now. Like I just loaded a PowerPoint, correct? Okay, so yeah, so can you confirm if you're able to see what I'm presenting right now? Like agents of cities, somebody can confirm this?
Yes, we can see it.
Ah, perfect. Okay, great. Thanks, Jonathan. Okay. So very quickly, so what we are going to discuss today is like how agents, right, over the time that we have seen over the last couple, like 1 year, we have seen that a lot of people have started building a lot of things on agents, and not only just agents, it's more like MCP servers and everything. So today I'm going to show you something which I had built initially on a framework called Decentralized Compute Core. And Agent of Sealed is a framework which I also presented at the Linux Foundation earlier this year. So what about the agents? But before that, a quick thing about me. I'm a computer science engineer with more than 15 years of experience. I'm founder of Axon Vertex AI. My work is completely into private AI and decentralized compute. I'm also co-founder and CTO of TrialBridge, which is based out of Germany, and it's very focused on clinical trial recruitments, and we are doing a lot of things on decentralized compute over there. I have contributed to NIST, NIST, which is part of the federal government of US towards uh, generative AI challenge and assessment of risk in AI. Uh, I have been part of multiple books which have been globally published in the area of AI. I also teach at Stanford University as a section leader for course 106A. And apart from that, I keep volunteering a few of the things. I'm also part of the UN AI ecosystem that is getting built under Express roster for getting people who can work for UN or can contribute to UN. So enough about me. So what is the backstory right now? So let's talk about the backstory. What exactly AI right now is shifting from a lot of us? That obviously we are looking at more and more awareness that these large language models every day something is coming in, like Nana Banana. Every time we are looking into cloud first, but then in certain industry like in healthcare, in banking, we are seeing a very immense transition from cloud first to data first because of the privacy issue. And that's where, those small models are coming in. There's a company called Liquid AI, which is based out of Boston, and they are doing a lot of things on small models. Google Gemini, they are looking into it. And for them, privacy, sovereignty, and cost is basically a domination thing on that. Security teams needs on-prem air-gap workflows, which feels like modern AI. Now, tooling is fragmented. When I say tooling is fragmented, there are multiple ways how you interact with your entire document ecosystem, your entire systems or LLMs. So at that point of time, what kind of policies that you're looking into, what kind of redaction, what kind of RAG, threat intel, and everything. Hardware is also limited because if you think of moving your entire compute to on-premise, then obviously the hardware limited. But again, because of the small models that we are looking into, and because of multi-agentic logic, there is a lot of thought around that how we can do. So let's go back 2 years back, and if you remember, like the big models were there, everybody wanted to say that I want to try a LLaMA 405 billion parameter model. But today, I don't think that anybody is using that, even though it is there. But I don't think anybody is using that. Right now, GPT-OSS has released a model which is 20 billion parameter model. But again, that's something that we know that a lot of people maybe use the 20 billion parameter model and not the higher one. So we need a framework where privacy and compute work together and not against each other. So how do we solve this? We create a modular on-prem policy-driven agent stack. Now, why I'm talking through this, because this will give you an idea that how when you build something, it gives you a way to create that ecosystem on top of it. So be it like a modular on-prem policy-driven agent stack, or something when we say like from a orchestrator. So when you think of it, like you need an orchestrator, a brain path payload out to be intent. And then each capability is an agentized service with clear API, which is like auditable. You also need policy as a code with guardrails. Now, guardrails has been there for very long. A lot of people have not used guardrail model as they want, but today, if you look into it, more and more implementation of the guardrails coming in. OpenAI created their own guardrails inside of it, right? And right now, the idea is that how you should use guardrail rather than use a guardrail model, but how you should use guardrail is also something. So it should be secure by default. And to show you when I run the demo, I have like two systems. One is this, and there is another one. So I'm going to go through another system. I can show you the compute which is running on the other system as well. So the entire demonstration, ideally, like I'm speaking to all of you over internet, but when we actually work, we don't use internet. It's just like the private LAN, all compute work together, and we just host the model by LLaMA and work on it. So sealed, what is sealed and what is S into it? So what we did and what we thought of doing is that the S stand for secure. We are going to talk about like Shield, Gemma, Llama Guard, Granite Guardian. So what really happens over here is like if you look into it, like we have, we'll do a normal post and the pipeline will start. And in that secure part of it. It will look into what kind of data is going in, the input-output moderation. It will do an audit trial and secrets which are there, which will not leave the entire ecosystem. Now, when I look into it, the orchestrator will always look from a guardrail perspective. Now, when I tell you all of it, I will show you that how many services are working together and how many agents which are working together. Each of these agents are running on their own compute, and each of these agents are basically built as a container service. Now, imagine that you have multiple compute, you have different compute. You can join all these compute together and host each of these multiple servers as a container, working on each of this container, and then expose them over like private LAN and use the compute together rather than to run everything. So this is one thing that we look into called something called guardrail service. Then we will when we look into it, we will also look into something as a verdict, which I have created, and we thought in the framework this will be very easy to use, where we say verdict safe and unsafe. So if it is a safe verdict, it will provide. If it is unsafe, it will not. The orchestrator will block and the payload completely blocks it. E is basically encrypt, like how you encrypt, like your password agent. So we are going to look into a password agent and we'll see that how it works actually from a password agent perspective, and how the policy parsing can happen when you use a policy on top of a password agent. So when for the policy, we will try to parse it through a vision language model to see that what can be inferred from that. And then we have ephemeral artifacts, or kind of KMS hooks for regulated environment. Analyze in this, we can always look into that, how exactly a system can analyze. A system can be analyzed. So for example, based on the intent, the model selection should happen. And during that, we would prefer to have the most robust model to go and check. So for example, if I want to check that if there is any kind of problem that is being defined, or any kind of SQL injection that I need to understand. So either I use my own foundational model, or I go ahead and start to use my fine-tuned model, or I create a RAG pipeline and I use that. But for all of this, this is again where you do an analyze kit out of the CED framework. Then you have optional FIS RAG. This is again for retrievable augmented generation. Now, all of these passes for guardrail and outputs are attributed to traceable. So while each of them are independently working, they follow the same pipeline that we initially discussed. Locate is to identify that if there are PI credentials. So we use something called Presidio. Right now, very recently, I think Liquid AI, they created on PII as well, a model. But so far, the best identifier which I have seen is Presidio framework by Microsoft, which is really good onto it. Then we look into eliminate. Now, this is something where we do like a redaction preview on a policy, where we mask it, and then you defang before any LLM sees it, and then you do a redaction preview, and then you actually go and do it, so that every time what is being sent to the language model and what comes from the framework, it's always a sanitized context for the downstream agents. And defend is at the last is part of what we call is more of like words with guarded wording. It never overrides safety. Like what it is, it will just defend it over there. There is no way that you can do it. And it's a policy wording, more of a compliance perspective. So which model, which policy, which build is fine. So it actually create a trace, and the defender will show that onto it. So what we are going to do is we're going to use a pathway. Now, when I say the pathway, I'm looking at an Gemma 3 model, which is 270M, which is a very, very small model. We're going to look into guardrail, input, block allow. Then we try to do a sanitize. We'll do again a guardrail defend. And this is a pipeline which will look into it. And then we see a password, which is going to call a password service. It will parse a text, image, generate. Threat, then it will call GPT-OSS analysis for risk impact mitigation. Now, all of this which is happening, it's not that I'm going to call a model, right? I'm not going to call the model because I'm going to show you in the real time that how it works. Wherever there is a requirement of any kind of embedding, it will try to look into the embeddings and then define it. Graphs are optional. So again, graphs, you should always look into it. Like when you use a graph service on top of it, right? So your graph services will be useful when you try to create a relational entity, which are not yet defined. And just to tell you that on clinical trials that we are building, our entire clinical trial analyzer and the medical coding agent sits on top of a graph. And that's what we are going to talk about in one of the future sessions of Notes 2025, which is Benio Forge. So I'm speaking over there, where we want to show them that the how graph and language model come together to create more intelligence, which is relational intelligence from a context perspective. So this is the pathway of it, and every step will log a trace from. And yeah. Now, decentralization. So since my focus have always been on the privacy side, my focus has always been on the decentralized compute. So today when you see when I switch my system, I want to show you that what kind of models I run through. And I will keep on checking on the chat. Please do ask, because I was thinking it would be more like people are promoted so that they can ask their question directly. So we are looking into microservices. So when I say microservices, we're container services, which we'll see. vLLM and OLAMA and LLaMA CPP. So we had three options to use. Now I'm using OLAMA because with vLLM, we know one thing which is there. vLLM is very fast, but then you cannot dock and undock just like OLAMA. So you can just say that, okay, release this model and upload another model. So we have a constraint. So I'm going to show you the constraint. So we have 16 GB of VRAM, which the system is. The GPU is 16 GB, and the one system which I'm running on is around 6 GB. Now, with 16 GB GPU, you cannot have all the parallel model. So what we are going to do is we are going to offload the model and onload the model wherever and however we see that. The small intent model is always resident and it keeps on working. Now, the best thing, or the benchmark that we have identified, we have seen that quantization perspective, Q8 is really good, and we want to use that. We are going to build this entire thing over Tailscale. I'm going to show you that these are stateless APIs, which are bounded, mounted volumes for each of the containers. Now, when the agents are down, it will do a graceful degradation so that we can know that when the agents are down, like let's say if it is bound out of memory or anything like that. A quick way how we are going to look into all of this is we are going to look into the telnet, which is in the browser. We are going to use a web app. The orchestrator is going to call all of the services, which is 441. The graph, if we are using a graph, it will be there. The embedding files embedder will be called on 4412 port. The password will be called into, these are again private ports that I'm showing to all of you, like 4409, 4410, and the guard will be finally on this. The number of models that we're going to see today working together based on how they choose to work together will be Gemma 3N, LLaMA 3.2, Gemma 3270N, Shield, Gemma, LLaMA Guard, Granite Guardian, and GPT-OSS 20 billion parameter model. So GPU Smart, the demo is about how you can be GPU Smart, how you can work on decentralized compute, open source model, and truly private. So before I go to showing you something, I want to quickly see if somebody has any question onto it. So where are the question? Any question, please raise your hand. I want to make sure this is okay. So Fabian asked, is OLAMA running in a single instance or there are multiple OLAMA instances for concurrency? For this demo, you're going to see it running on one instance. But for production grade, what we have done is we have like 6 or 7 compute working together, and then all of them are running the OLAMA server instance. Now, one thing which I want to tell you, since you asked Fabian, that OLAMA has this something called num parallel, right? And when you use num parallel is equal to 4 or 5, it doesn't mean that you can really use your parallel models. If you're trying to use that, make sure that you use LoRa adapter, like low rank adapters onto it, so that you can use parallel. But then you can have running in multiple instances. For example, I have my system running on this laptop from which I'm talking. So I use a Linux machine. Every machine is a Linux machine for me. So, and the other machine which I'm going to be logging in has a 16 GB GPU. So based on the compute, I can run multiple instances and multiple, compute instance, I'd say. Does that answer your question, Fabian? Okay, perfect, great. Any more question, please? Raise your hand, ask questions. Rudolph, Jilfish, Fabian, David, Ermin, Alex, Merrick, Carl, Catalina. Okay, fine. So let's go to demo. I love demos, by the way. How do I see while you people are also looking at my screen? Okay. Let me do one thing. Okay. No, sorry. Yeah. Let me do this.
Like I can also alert you if anybody asks a question, so you don't have to move the multiple windows.
I'm sorry, what?
I can alert you if anybody asks a question, so you don't have to worry about multiple windows.
No, I'm just trying to set it up. So you both can see my screen as well as the participant window, right?
Yes.
Oh, perfect. Okay. Okay, first of all, what I'm going to show you is, so going forward, I'll be doing a lot of things uh, on the console, right? And for for the instance of work, we will go to the UI as well. But first of all, where this entire compute works in and how it works. So first of all, you spoke about tail scale, right? So I'm going to show you that I have a tail scale network. So these are all the machines which are there on my network, right? So this is again a decentralized compute network by one of my friend. We joined this network and we try to see how we can collaborate together on compute, right? So I'm going to show you this is mine, right? So there'll be other, I've got like 5, 6 machines over here. So let me show you what is uh, Tailscale IP. So sorry. So the current IP is 1 at 1. This is the current IP, right? But, and before that, let me quickly show you that what is the compute over in this system. So over here, I have a 6 GB of VRAM, which is running over here. Now, I will just say SSH 100.64.0.2. So this is again this is the machine that I'm going to log into the other one, which is basically the one with the higher compute, like 16 GB of GPU. Okay, so now I have joined it over here. Now to show you that what is so right now, if you see, I'm on this particular machine, which is on the same tail scale, and I'm connected to the other one. Now, to show you, let me do one quick thing is, so if you look into it, I have a 16 GB VRAM onto this, which is going to run. Okay, so we're going to use 16 GB VRAM on this. Now, before I start, let me show you that what kind of different um, data service that I'm running over here. So now, if I look into it, all the one which are part of seed are the one which is looking into it. So if you look into it, we have a seed gateway for services and orchestrator. This is from web, eliminate, defend, guardrail, passive service, secure, analyze, anonymizer, graph, uh, and defense. So if you look into it, all these services are being used by this compute. Now I can hold and I can run this compute anywhere. So the idea is you build a container and you can run it in host this container into whatever device and then run it from there, because each of these container are individually looking into and individually work according to it. Now the good thing is that when we look into each of these container, right now I have OLAMA services running on this. So when I say OLAMA services running on this, let me show you. uh, So if you look into this, I have got all these models which are kind of available on this compute. And if you look into it, I have got like a Quen 3, 3B Thinking, DeepSeek, Gemma 3, Shelled, Granite, Llama, uh, Granite, Gemma, GPT-OSS 20B. So each of these model, when I start to work onto it, and when I say that, okay, I'm building this, there will be one particular thing that you have to understand, that when we load a model, right? So if I load this model, this will take around 9 GB of my GPU, for example, the codecs. On GPT OSS, when I load this model, it takes around like 12.5 GB of GPU out of 16 GB. So how can I work with multiple models on the same framework, right? So OLAMA has something called what we say as keep alive. So that's where we do a onload and offload, and it's a very brilliant way to work on it. One thing people have asked me, that how do you make sure that the intelligence stays on? So you put it in the context. So you create the context, keep the context, and then whenever the new model comes in, push the context to the new model. So in that way, you are interacting with different models, and yet you are building something. But I want to show you something over here. This is going to be very interesting. So any questions so far on the compute side, on the model side, and on the container side before I go and start running these services? Any question? I'm looking at the chat. No one? Okay. Please exit from this, and I'll create a watch window. So now I can see that my watch window is configured at every second, so that I can see that, okay, how this entire thing is working on every second. So let me do this. Let me place this up right over here. Okay, and this is fine, right? Okay, let me go here, the agent of sealed. Okay, so if you look into it, this is running from 100. Okay, just a minute. Window. Yeah. So I'm going to run this from 100.64.02, right? Now, a quick thing is that when I look into this particular okay, so if there's any question, just let me know. Okay, I'm going to use the entire screen right now. So what I want to show you is that what we are looking over here at this point of time is something where we say that, okay, this is where we are going to see that how the model works, and the model, like how the GPU compute works. Over here, I want to show you that everything is working basically looking into it and running locally. When I say locally, basically running with open source model, right? So we'll start with a simple high, a workflow of simple high and everything, and see that what it actually entails. Okay. So before that, let me do one quick thing is I want to put this out and over here, put this over here, right? So now I'm going to say hi. So if you look into it, I'm just going to press hi and you'll see a compute change over here, right? So if you look into it, it takes 32, 33, 6 GB, and then again 0, and then again 33. So what has happened over here is that, hello, obviously for a high, you are saying that what is happening. And now if you look into it, the model last turn, they run it two model, right? So it runs a cardinal input, which is the shield Gemma, and the defend complete, which is Gemma 3 and A2B. And it says, hey, the cardinal vertex is safe, the primary shield which was used for the shield Gemma, and the model vote. Now, think of this way that there is a voting category that how models respond, and then what the system does is that it creates a voting and say that, yeah, this is safe. It's not just one guardrail. So we do a multiple guardrail votes. So be it with Shield Gemma, be it with Llama Guard, or with IBM Granite. And then the best model, which is on the safe category, is being chosen over here. Now, let's say I will ask him, can you generate a password for me? Right now, if you look into it, it says it now. If you see, one quick thing is right now there is no model yet. Why? The last decision was given by Gemma 3N. Now the model, which is a router. Now it means that the context is holding. And when I say model router, this is basically being worked by the Gemma 270M model, the small model, the intent model. So the intent is holding, and it says no policy in session. So what do you mean by policy? So let me tell you an example, right? So we must have seen these kind of like average, like at least one number, uppercase, lowercase, and all of it. These are what? These are kind of policies for me. So let's say, can I infer a policy from here and create a password, right? That's more important because when we look into it, we want to see that how you can use your agents. And each of these are basically agents which we are going to do it, right? I'm speaking to my chat window and it is calling an agent to do all of this work. And at the same time, I'm also showing that how it is each of the agent is using their own specific compute and then coming back, okay, and specific model as well. How and which model to run, that is being understood by the intent because the intent is defined and trained that it doesn't create. So as an orchestrator, it's not like there is a defined path of the orchestrator. The intent and the model defines based on the queries being asked that what should be the model, what should be the agent, what should be the task, and based on it, it actually does it, right? So now what I will do is, so there are, I think, two images. My password also over here. So what I can do is, let me try to put add from image. So I'm going to say password policy. So let's say I add one of these. I hope it works. Uh, so my password. Now I say parse image, right? So let me also run this side. So parse image. So if you look into it right now, again, the GPU is parsing. It takes like 76776 GB. So now what happens that it parsed it, right? Now over here, if I look into it, there's a parser image, but then all the entire thing, what it is, the policy, it is hiding it from me, right? So it will not be showing what is the exact thing so that I can never know. So the policy is again hidden and being held inside the framework on the top of it. Nobody will see that what is minimum length or everything because I don't want anybody to see that what the policies are enforcing. Now, if I say generate a password, Now from the model router, if I go ahead and say generate a password, I'll see over here. And now if you look into it, the password service has been invoked. So from router, it has gone to password service. And now if I look into it, it has generated the exact same way of methodology what it can use. This time, it did not use any kind of compute because it just called, it had the policy, and based on the policy, it generated using a random analyzer. Now, when I say a random analyzer, we are using SHA to SHA-512 and AES-256 to see the strength of each of this password. So when we say that the password strength, there are always password strength. If you remember that there in many of the websites, when you put up a password, it says the password is safe for 1 day, the password is safe for 2 days, or password can be broken in 25 minutes, password can be broken in 1 millennia, right? How do you understand? So this is where we look into hot policy that we call out of it to create password which is on that. Now let's say so if you look into it, we are just going through a different model. So each of these agents are calling different agent, each of these calling a different model altogether. Let me try to show you for this. So OS, right? So let's say one of these things. So this is SQL injection, right? So let me take this, the SQL injection, as we see that, like, if a URL is like this, ideally it should be a SQL injection. So I'm using an OWASP, blind SQL injection, and want to understand. So how do you use this, right? Again, so let's say, can you analyze the threat level of this request, right? So let's say I just say this, and it should again invoke a model. So let's see what it does. Okay. Now, if you look into it, it has started pushing the model, and now if you look into it, 13 GB of GPU has been taken. Now, this says that the only model which is going to take 13 GB is basically GPT-OSS. Okay, so now the last model used the password generate was password service. So it's still running, it's a big model. It takes time if you look into it. It is on 25%, it is trying to analyze. Now, when I say I have a RAG which is running with the models, which will go and check the CVEs, which will go into check on the OWASP threat monitor documents and see that what it can be. Now, if you look
Sorry,
into,
there's you, Miss.
sorry,
There's a question for you by Fab.
oh, there's a question. If I understand correctly, it doesn't use any compute because LLaMA is not called the password service or the password service model, smaller model. Okay, so good question and very good point, right? So the password service is, so okay, let me tell you this. You should not be using password creation using an LLM at any point of time. So algorithms, the compute mathematical algorithm, the SHA-3, right, AES-256, and then you do a hot offloading, hot encoding. These model generations, when I say model, these are basically algorithmic model generation, not like LLMs. So when you build this will go and check that what kind of stickiness are there and how robust is your password. So the password service is itself working only on CPU computation, and it does not use any GPU. It does not use OLAMA service. OLAMA was used for this particular use case. Where is the dot? Over here. So when we created this policy, right? So when we first said, can you generate a password from me? He said no policy, because I made it sure that any password, if you're generating, it has to be through a policy. It works. And that's why I created this bank password. And I said, okay, I want to use the policy from this password, right? Like I need to have 8 to 15 character, mix of alphabet, and special character of all of this. Now, if I look into this policy is sitting inside this image, right? And I want it to be agents to be very smart to pick this up. And that's how this will go, and it started generating a password from there. So the policy defined that this is the rule, and based on the rule, it goes and do a CPU computation, runs all the algorithm that has been defined from a privacy perspective, and then generates. So LLaMA is not used. Does that answer the question? Perfect. Thank you, Fabian. Um, should I continue? Like, was there any other question? Like somebody said. Um,
Was it?
that's it. Okay. Perfect. Okay. I hope everybody is liking this flow. Okay. So we are still, a little bit away from there. So let's see. Okay, so now what I did was I created this, right? So the analyzed request. Now, if you look into this, one quick thing is what I wanted to show you is we used different model, and if you look into it, I'm offloading every single time. So right now, again, my GPU is free. Now imagine if my model has been there. With LLaMA, you normally keep that model, right? So you normally keep it alive. So what I have done is that no, I don't want the model to be alive. When I need, I will invoke it. For my intent, I will use a 270M model, which can actually basically on your RAM, right? It doesn't need a GPU basically. So for my intent, everything is running through on a RAM or a CPU. I don't need it on its. It doesn't need a GPU. I'm not even running on a GPU. So that's why every single instant that you look into it to analyze, to intent create, and to answer, it is using the smallest model. But for each of this, the heavier task, like we used a computer vision model, right? A vision language model. So that time it used Llama 3.2, and then it chose that it should use a Gemma model. Now it used for this entire threat analysis, and this again, it's the orchestrator. There's no workflow for this. The intent says that since it's a threat, use the biggest model. So the intent model, which is Gemma 3270M, decides this. So now if you look into it, the model which was used was model GPT-OSS 20B. But 20 billion parameter model, when it was used, it actually used, once it is being used, it will immediately it made my GPU free so that I can keep using my pipeline, keep using my compute as it is, right? Now, this was something which I wanted to show you from a threat analysis. So in threat analysis, we did this. It created risk, impact, mitigation, and everything. And it looked into the CVE, it understand it, and then it said, okay, fine, let me give you this. But then let's say that what really happens on guardrail, right? So far, we have seen that the system is always giving me an answer. What happens like when the system should not give an answer? So So let me see if I ask this question, what will happen? So now if you look into it, 563 was the first, then it went to 6729, right? So it is running one model. The first one is another model, and it says none. Now if you look into it, it just say it doesn't respond anything. It just like goes away and it doesn't let me do anything, right? I can ask it another question. Can you help me with a way to, right? So if I do this, right, this time it went to 202823. Now it is looking into 1419, again 209, then again 27C, and then again. Now it says the entire thing is blocked. And let me say, what does it mean? Why blocked? The guardrail decision, now it says it's unsafe. The primary shield is being used, shield Gemma. The model votes, each of them has identified it as an unsafe. Now, what do you mean by shield Gemma has created unsafe? Yes. Granite Guardian, has been saying unsafe, and llama is also saying unsafe. So let's see what does it mean, right? Let's go to llama. Okay, and what was the first one? The shield Gemma, right? So let's see shield Gemma over here. And if you look into it, if you see my model, again, my GPU is free right now, but it is very ready. So yeah, now shield Gemma is again a set of instruction model for evaluation of safety of text prompt. Now let's say that how it works. It actually says yes or no. Now with this yes or no, I am defining the voting parameter for me, right? So I'm not using one model to let it decide, because again the bias of one model could be there. This is one of the biggest problem, that why did I do it, right? So you can have a bias onto it. So that is one. Now granite, let's say the unsafe category of granite guardian. So again, this is an internal system which actually works, and then reading from the internal data, I'm also looking into that what could be there. Now, if you look into it, risk detection, so you can always say that what kind of risk detection which has been there. All of this data point are going and hitting my intent model at the back end, and then it identifies as the final output or the final block that it should be there, or this is how it should be. So on this, we are saying harm and the social bias. It's a social bias, then it's a jailbreak and everything. You can always create your use cases. You can always use for a particular aspect of it. I don't use a particular aspect. I don't set systems. I don't let anything to do as like you set the system. All this thing which you look into, profanity, violence, these things are being defined by the intent model, which is the 270M, when it understands that whether it is a profanity, whether it is a harm, and then invoke the guardian model inside the OLAMA, and then it runs the model in unsafe category. Llama 3 guard, Llama Guard 3 is a very beautiful classification on these aspect of it, right? So before I do this, what did I ask? Can you help me with a way to commit suicide, right? So commit suicide is what? Like self-harm, right? So if I look into it, Llama, this is the Llama 3. So if you look into the taxonomy part of it, it says violent crime, non-violent crime, sex crime, all of it, and then it say suicide and self-harm. It automatically selected because the model does it, but then I'm not trying to overqualify onto it. I'm not trying to over-classify based on the hazard taxonomy. I'm just using as it is. And then I'm creating a voting parameter, and based on the voting parameter, my cardinal voting says unsafe, and that's why the response is completely blocked. So now, if you look into it, the model was guardrail because it's a mixture of model. It's not one model which is doing. My guardrail service is not model. It's a mixture of all the guardrail models, and you can add as many guardrail models on top of it so that it can keep on, like checking into each of the guardrail, create a voting system, and then define onto it like whether it is safe or unsafe, or whether I should generate the answer or not. And at the end, let's say if I say thank you, just to say that how did it, so the first thing is like, oh, it has been blocked. So does it mean that my system will not respond? Okay. Now if I do this, if you look into it, again, my GPU compute takes in, it goes, checks into a quick rail, and now the guardrail decision says that, okay, safe. And that's why I said, you're welcome, I could have on you want some question again. Is a question I'm going to explain. I'm ready with the next request. So now if you look into it, the last model was that right now for this uh, final message that we sent, the guardrail was shield Gemma and the Gemma. Now, if I go through the top and see that what we have demonstrated, what we have seen is, we started with a high, the model was Gemma 3N, then we used a router, the password service, which is compute intensive. Again, do we need a GPU based operation? Do we need an LLM based operation? It should not be defined by human. Let it be defined by the intent of it. And that's where the beauty of LLM should be, right? Like, so for password generation, I will never, like for any kind of password generation, I will never ask an LLM. I will always use my own algorithms. I will prefer to use my own algorithm based on the policies that we are defining, right? So then password service, then we go into look into GPT-OSS 20b. Then again, it worked onto Gemma 3BM. Over here, it looked into like 1, 2, 3 models, right? So 3 models, and then it ran 3 models and gave me a algorithm. And again, right now, if you look into it, this entire thing had run through again 2 models, and the highest model vote is on the real Gemma. But this time the answer is given by Gemma 3N, and it's not basically. So this is Gemma 3N 270M, which is actually processing and giving this answer, right? And over here is not even using a GPU. So this is what we say a complete use of decentralized compute, open source model, policy-based system to create as simple as this ecosystem, this structure. Now, before I open up for question and before I go to the next phase of our talk on the demo, I want to tell you that think of this entire exercise that we are showing. How does it help? You are working in an organization where you have your organizational policy, right? So you can always use those policy to work alongside a model and use how you use your data, you use your models into it. There has been a news, and let me be very honest with this. There was a news that Deloitte, or there was another, I don't think which was that, but there was a news that one of the big four consulting firm, they did a study for Australian High Commission and in Australia, and the entire report cost around $500,000, and it's just a news which I saw on Twitter, so I don't know the depth of it, but there have been multiple things like that which has happened. And there is no way the hallucination data has been used. How do you create those reports? Let's say everybody uses AI for the work, but then you have to make sure that you use a policy framework where you say that, okay, whatever be the generation be there, at any point of time, I have policy. So before I go and go to the next demo, I want to take some quick question over here. Any question? Any question? Rudolph? Okay, perfect. Okay, I think we are good to go to the next thing. Now, let's say we spoke about this. Now, the next thing which I wanted to show you is, like right now we looked into this compute, right? So what I'm going to show you is right now working on my compute. Now, before that, let me first go over here, close all of this. And over here, I'm not going to use this compute anymore. So I'm going to exit from here. Now I'm back to my own machine, which is this one. Right, okay. Now I'm going to use a simple 6 GB compute. And over here, let me show you something. Oh, wait, why is it not working? Please ask questions. Meanwhile, I was not knowing that it was going to be so quiet. Okay, all of them are running. So let me see. Yeah, okay, simple agent. You go to calendar, Google Calendar. I don't have anything. So let me try if this works. It works. Again, what I'm trying to demonstrate over here is, where is the watch? Where's my watch? Okay. So what I'm trying to demonstrate over here is that how you can use a simple model. And a use case for that will be that how, for example, when I actually work, right? So I normally don't use. If you look into my system, and if you look into my code book and everything, you will never find that I use any AI or anything. I just write the code as it is, right? Like, I have my own reservation of using AI in a way to write codes. Again, that's person to person, but then I have seen that sometimes it breaks the system. So I prefer building everything by my own. If I use an agent or if I use an AI, I don't preferably use coding agents of GPT. What I normally use is a Quen coding agent if I need to, because I know that I can define my intents. I can define that what kind of data has to be there, what kind of model it should generate, what kind of code it should generate. So anyway, what we are trying to do a demo today is this is another demo where we want to show you is like how do you build a simple agent. Okay, a simple agent that I am looking into it. Let me show you that what it means. So let me over here first show you the tree of it, right? So what I've done is I have created a agent service. In this agent service, I have different subfolder, but there are like if you look into it, I have different services running in. One is an agent, an API, an MCP server. Collab, this is just for a purpose that we wanted to see that if I want to run through Collab, but I'm not a big fan of Python notebooks. But again, it's fine. It's there. We have Docker Compose YAML, README, the secret token, and then a stream data. Now, before this, let me also tell you, why this structure is needed or why this structure is needed, right? So, what we are trying to do is we want to create a calendar event. I want to talk to my private LLM, and it should create an meeting and send an email to whoever I want, right? Just from there. Now, one thing which I want to tell you is that think of this use case. I know this is a very simple, very easy. People normally just plug and play with uh, normal models, right? Like in a GPT, you just plug and say that, okay, fine, send an email, send an calendar invite. For me, this use case comes from or stems from the fact is I normally, when I work with a lot of data, when I review, so I have a tendency to either use a note, like a notepad, right? So I'm trying to note something. Imagine that people are saying that, okay, if you want to remind yourself, you create a note. Half of the time, people just go and write something. Okay, create this event for me. So my idea is, why don't I have like a complete own compute which is running on my system, which is running on my data. I have like 1 terabyte of data on this, 2 terabyte of data on this other machine, right? So I want a lot of document which is there. So let's say I'm reading a research paper. I said, okay, remind me that I should read this research paper on this day, right? Now, what portion I can use it through an embedding thing on that particular document. And from there, I can create a calendar invite right from the comfort of my own thing. And I don't have to push everything to onto OpenAI or anything. Today, if you want to use OpenAI, you can create a pipeline to it. But again, to access all the document, will keep on uploading the document. I don't want that, right? Why do I want to do that? I don't want to upload my documents. I don't want to upload my research. I don't want to upload my unpublished research or whatever it is, right? So when you do this, this is where you understand that how it works. So before I quickly tell you that how this entire agent is right now working, so I have, okay, sorry for this. I've been trying and testing to show you this agent. So there will be some dead code which I removed and everything. One thing is that what we are doing is for this agent, we have a backend. Now, backend is I'm using an LLaMA base and I'm using the Quen 2.5 3B instruct. I'm using an LLaMA timeout of 40. I'm retries, okay, 2, right? This is again the format of the GPU load, and this is what I can normally use to reduce the GPU load. And I can say, okay, num context 2048. Normally, if you know with LLaMA, the default context is set always at 2048 or 4096, even though the context length is 2,128K or whatever. You have to reset it by configuring your LLaMA file or GGUF file, right? So this is something the first where I'm looking at the backend. The core is basically where I have different calculate services, which is to do URL, which is again running on this services as well, and that calendar which is running on the port 7100. So if you remember when I first did this, I kind of created a Docker compose up and I put this, it started all the services. And now if you look into it, these are the services which are running into it. The to-do and Kelsey, they are basically onto the same network and they are hidden from the port identifiers. So that's why the ports are not being shown over here. The other two-way that we look into it is like 7,000 and 7100, which is 7100 the calendar. 700 is again from the agent. Now the agent calls the calendar. The calendar by in 4 calls the calendar service itself, and 8501 is again the UI. So either we can test this entire system using these kind of thing which I was testing, right? And it will and I just copy pasted that how it works and how it not. So we're going to do something like this. So either you can do it from from the comfort of your command. I know the comfort of command because I like the command prompt better, or we can use an UI. So we'll use an UI and show it. Okay. Now before that, one quick thing is that right now, if you look into it, this is my calendar, which we are using over here. So how do you use a calendar service? I'm not going to go deep into it because it's a self-explanatory structure which is being defined by uh, Google. So you can always go and find out the easy steps over. Sorry, uh, like how do you use your calendar service or anything. So I'll go to the console. I'll quickly show you. I'll not create the entire thing again, but I'll just show you. So normally when you create a new project, so right now you see I'm creating a calendar agent. You will first of all, you'll go to API services on this. And once you are into API services, you will create an enabled API services. So in this, you will just going to enable the Google Calendar API. And if you hit, I have 142. The error is again 3%. So during the demo also, you might see that there's a timeout error, and that is not because of the system. That is because when you send a timeout, there is a timeout onto the Google Cloud API for calendar. So either you have to wait for some time, or you have to look into a methodology where you do a hook service. So I've not created a hook service, but this is something that you should always know, that there is always an error margin from the calendar itself, right? Now you have to enable it. You have to find and enable it. When you click on enable API and services, you will have to find out the calendar and just enable it. So if you click on this calendar API, you have to go and say enable. So when you enable it, say API is enabled. Okay. So once you have this, when you have enabled it, what you need to do is then you have to go to OAuth consent screen, because you're going to create a consent to let the service use it, right? So when you go over here, you will find that the metrics no data is available. So what you need to do is go to data access, and over here you will see that there is scope. So when you say add or remove scope, so I have created a scope to view all my calendar events. So when you click on add or remove scope, you can have a scope which is authorization to calendar events, right? So I can have every single thing, whatever scope which I have over here to do, like for example, user profile and everything that I want to understand, right? So when I say calendar service, you can think of multiple use cases. Like you can connect it to your Google Docs, like large Google Docs, where you see that there's a big doc which is sitting over there. Download it from your Google Drive, analyze it, and then put it right. So you can do that if you are very upfront on using like an open source model like me. So this is one. Then audience, you click on audience and you create a user. I have created an add test users. I have to create an actual ID. So I have created the ID axonrobotics@gmail.com, and it's that user onto it. Then we look into clients, and when I say client, I will create a client on this. So when you create a client, it will ask you a very specific thing, what is the name of the client. On this, the redirect URI. Now, this is something where I do an auth check. This is where the redirect UI, like for use request from web server. So even though I'm sending it locally from my local onto Google, I'm just defining that this is the auth callback. So if the request is coming from this particular thing, not on the IP from the local host, which is defined into my client program, right? It will just do a callback and send the request from here. Okay. So all of this which is there now, let's go back to our calendar agent project and put them into calendar, right? So let's see how it works. And then this time, let's see. Okay, put it out over here. Now let's say I say hi. Okay. Now this is very different from the previous demo that we were looking at, in that you had guardrail and everything. I did not implement. I'm just trying to show you that if you can do it. And again, if the demo fails, I'm sorry, like it completely like how the API services work. So if you look into it, it is again taking some time, to do it. But why is it taking this much of time, or why did it take? I'm just using one model, but then again, for a high, the reason why I'm doing it is because it is calling a function tool. Now, why function tool? So let me tell you this. So when I look into the tool MCP, and when I look into my calendar server, right? If you see that I have defined each of them as an into calendar function tool. Now I have defined when it is call status, right? Like calendar has to be authorized and calendar not has to be authorized. So when you build your own client from the calendar client, you will get something as like a secret token, right? And you will have a token like this which you have to define, which is again you can download it while you define your calendar service. And then you also have to have it over here when you get client ID and secret, right? So you can use it and then and do it, right? So you have to define all of that and in a way. So this again, I just said, this is going to use the calendar server, which is going through different tools that has been defined, right? And it says, okay, these are the certain tools that will be used the way how it should use to delete or to anything onto it, right? But then it will go through everything and then it will define that what needs to be done. That's why we are seeing that kind of process that even the agent. What I'm doing is why I'm showing the answer like this, the agent, because when you talk to calendar and all of that, you definitely do not want to see, hey, I have set your thing. I want to see that how the agent responds back. So you can always see that what it is there. Though it is responding as a message, you can also define it that be very specific, be everything like that, right? Now, if you look into it, this time I'm not offloading the model because I'm going to use the Quen 2.5 function, because Quen 2.5 model, which is 3B model, which has a function tooling capability calling. And so I'm using the function calling and tool calling capability of that. So I'm keeping the model, I'm not offloading it, I'm keeping the model here. Now, so I'll just say, how many meetings do I have this week? List them, okay? So now if you look into it, it will go over here. Tool will go and immediately call my service. This the LLM first calls the agent. The agent will define that, okay, what needs to be called. The agent defines the tool. The tool understands what needs to be called based on the intent, and then the API is being called. So it says zero meeting. So if I look into it, zero meeting over here, right? Now, let me do one more thing. Use this one. So I'll say schedule. Oh, sorry. Schedule a meeting. So let's say what it says, right? So see the spelling mistakes and everything, right? So, oh, like over here. Right. So let's say schedule a meeting for 16:10 from 10 a.m. CET to 2 p.m. CET. Now I am in IST. Okay. So my timeline is in Indian Standard Time. So what I'm saying is that it should work from 10 a.m. CET to 2 p.m. CET, and invite Krish.Dasgupta.official to the meeting. Send a good description of our agenda about building AI agents with open source model, decentralized. We will be serving something serving veg, non-veg, vegan for refreshment. Create a good agenda for description. Also add some dessert choices like cakes and pastries. This is what I'm going to send the message as. Okay, so I'm going to say send, and let's see what it does. So now it invokes a model, it calls and quickly does it. So if you look into it, it says scheduling a meeting for 16th October 10 a.m. CD, blah, 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 create a good agent. This is what I have said, right? The agent says that it has been created. Now I got like a instant message as well. So I'm going to show you first. I go to this, and if I look into the meeting agent, if you look into it, the way it has automatically created. Agenda, discuss building AI agent using open source model. So if I go back over here, let's see like how it has been a better person. I said schedule it. So if you look into it, it is scheduled for 1:30 to 5:30 p.m. and it is 10 a.m. right? So if I say 10 a.m., so it is 1:30 p.m. in Indian Standard Time. So since I'm on IST, it will automatically convert that, right? So it has taken it and say that, okay, now meeting on AI agents with open source model, right? So I did not say that what should be the way of how it should work, right? So say agenda is discuss building AI agent using open source model, explore decentralized compute and its implication for AI development. I did not say these words, but it was there. And then it automatically created a very good way, refreshment, vegetarian, non-vegetarian, vegan, dessert option, cakes and pastries. So, and it also invited me. So if I go back and quickly take a look onto my account over here and say, I feel, yeah, if you look into it, it says Action Vertex 130, and it has sent me an email as well, right? And it is all happening through my own local model that you see, right? So now I can go back and say the same thing. Um, I'll just copy this, right? And let's see if it can work. Now, there is one thing that I want you to do. Sometimes what happens that when we send a calendar API service, and be sure that you read about, we use the free tier and not a production tier on Google for these kind of checks. When you do this, make sure that you understand that in the free tier, there is a rate limiting that how quickly can you send services, right? So sometimes what happens that your API is hitting and it will stop, right? It's not like concurrently doing it unless until you're in a paid tier or anything. Now, if I say how many meetings, it again goes back, calls the tool, and comes back. Now it says one meeting. When? 16th at 13:30 CET. What is the meeting about? Meeting on AI agents with open source part, right? Now I have this meeting. Let's say I go ahead and say, so if I say delete the meetings and events, right? I should think that should work. Again, the API call has to be like synchronous and asynchronous at the same time. So let's see what it does. So it should invoke the model first, do a function to calling, and then it will call the API. So the model is invoked, which understands. So it says I manage your thing, schedule the meeting and everything. So it did not go and hit the API so far, right? So let me try again and say delete all meetings. Now again, it is invoking, doing a function to calling, trying to understand that should I be able to delete it or not. I'm waiting from the API services to do a auth callback and see what it returns. So if you look into it, this is where I'm saying that if the API, since why is it onloaded? Because it is still running and waiting for the response. That particular model cycle is still waiting for it. It's not just invoking and just releasing it. Now, if you see that it did the same thing which I was expecting, it did a HTTP connection pool, host region, and right now. Now, I will tell you one thing, right? If I keep doing this again, right, you will see one thing that will happen eventually. And this is the problem when you use, API services which are rate limited, right? It should again go back and say that, okay, uh, it should again fail. It should not work because I'm just using different kind of API services back to back, right? Now, if I look into this, if I do a refresh, after some time, you will see that, uh, the system is not here. The meeting request will be deleted.
Sorry to cut in with
Oh, sorry. Okay, wait.
you conclude shortly. There are only a few minutes left, but I guess someone answer questions in the chat you might
Oh,
ask.
yeah, yeah, sure, sure, sure. What function does the calendar scheduling app tools via have LLM? Only do specific tasks like schedule, like cancel work, or is it possible to dynamic changes? Like, yes, you can do it. So for this demo, I just wanted to show you. My idea was to show that how you do a real-time update and changes. So that's why I wanted to create this demo and show it to you. So yes, and if you ask me that, can you do visual all appointment? Definitely you can do that. The only thing is make sure that you create your intent properly when you create your calendar service, right? Go through all the events that are there defined in the API first, right? For example, I will tell you because I wanted to show you this. Because of the API thing, I'm not able to do that. When you cancel an event, you normally say this is the reason of cancellation. Through API, you cannot do directly. So you have to use a body attachment to the API and call through another API to make sure that when you do a cancellation, a note also goes through. Like normally when we cancel an event for a specific one. So for the question that possible to dynamic changes, reschedule all appointment of the day when appointment is cancelled. Yes, we can do it, given that you have provided that how it should change. So if you have a scheduler, it can definitely do that, right? Is it possible to do a dynamic calendar change, like when evidence cancel, it triggers calendar reschedule? Yes, if you give that kind of an intent and a permission, it will. What it will do is it will cancel one event. For that, you have to pass the event ID or the event name of the like the name of that particular meeting or the to-do item list. But one thing I have to tell you that when you use calendar events, right? In calendar events, they are mapped not by words, they are mapped by the ID. So what you need to do is that before you call an event through LLM, what you need to do is first call them, invoke the detail of that calendar event. When you invoke the detail, your intent should automatically, and your function tool, when it is getting the detail of that particular event, it should automatically get the event ID. Then map it to the event ID in your function to code and say that cancel this event. So when you do that, right, even though you are typing everything as the same, for example, I can have multiple event on my calendar with the same with the same date with the same time, which will overlay with the same thing. So that's all. So if you have all of it, then one cancellation and the entire event, which is for the entire calendar events for the day, that list also comes in. Now, if you say that, now this is something that your logic will say. So if you have asked the LLM, okay, redefine it or define it in such a way that my calendar, if the event is cancelled or the event is no more on the calendar, make sure that all my other events move up like for half an hour. Every event should move up by half an hour. So it will start to reschedule every event over there. So that again, the modeling has to be done through you, or you have to make sure that each of this function too, because again, we have to make sure and we have to tell you this, and this is very much important for us to know that LLMs do have a context, yes, but then again, with function tooling and all of these services, you have to create your context around those tools. Unless and until you don't do that, then it will not work. That's where what I think is that for each of these, even for the calendar model, I would prefer to run it using a small 260M or 1 billion parameter model whose job is to just understand what the agent is and the agent memory with its own compute, with its own LLM model, so that it can interact with voice intelligence and then it can interact with the chat model that you're using, and it could be any other chat model. Does that answer your question? Okay. Perfect. Any more question, please? Uh, by the way, I think that we are on time, but one quick thing is, I hope, okay, there is a Q&A. I'm sorry, I did not see the Q&A. Oh, it's 25 minutes, sir. That's very live. No. Okay. So I would say that if anybody is interested to you have my contact information, so please be this is where you can reach out to me. I'm also available on um, this is my email address, and I'm also available on LinkedIn. So I'm giving you my LinkedIn ID as well. So connect with me. Anybody who is who is interested to work on decentralized compute. So I work with a lot of other folks from a research perspective. Happy to kind of onboard you guys. We're trying to publish two paper on decentralized compute by early next year. So if you want to contribute to it, work with us on decentralized compute, understand the world of compute and algorithms and the cool things, please welcome to join hands. And for any other help or thing, you can just reach out to Marija, reach out to me, and I can help you out with. I normally have busy schedule on the calendars, but I can definitely make time on the weekend to join you on a call or to answer your queries. Any more questions? Okay.
Thank you so much. We
Thank you so much. I cannot hear you. I cannot hear you. I'm unable to hear you.
Can you hear me?
Yes, I can hear you, but I lost you for like quite some time. So I cannot hear you. Like,
Joining us today and for this workshop. Which we have run out of time to leave something for the 15 minutes before we come.
okay, sorry, the voice is breaking. Is it just me or everybody is having the same problem? I'm not able to hear you properly. The voice is
Maybe
breaking. Oh, okay. Marek is also saying same here, can't hear. Yeah, like your voice is going like up and down. It's breaking through and through. Was my voice like clear for everyone? Quick, anybody who can confirm, or did you face the same problem while I was speaking?
is it better now?
It was clear through the entire presentation. Okay, so let's give one more try. Like say something because I think like other folks are also unable to hear you properly. I'm so sorry.
I have cut to another network, so hopefully you can hear me better now.
Okay, you said that you got to another network, so it's better. Is that what you said throughout, or there was something else that I missed? Okay, perfect. Okay, great. Yeah.
Everybody for
Okay.
joining. Thank you. We are going to be going on to a 15-minute break and returning with our next.
Absolutely, and thank you everybody who has joined in. I'm sorry that it got delayed, but happy to stay connected. And I don't know if this is being recorded and been shared with everyone, but do share it with folks who have missed to join this. And if they have any queries, if they have any problem, if you want to kind of work with me on open source project, just hit me up. More than happy to work with all of you. And thank you, DSC DAC team. I think it's an amazing opportunity to grow and to learn. For instance, for this presentation, I also learned a few things. So even though I'm on the other side of the table where I am talking and you people are listening, I learn, like for example, Fabian asked me a question that it is possible to do dynamic changes. I have never tried it, so maybe I'm going to try it after, like a couple of days when I get some time to see that how it works, right? So it's always a learning opportunity for all of us. And thank you so much for waiting upon me and waiting for this. And sorry to all of you for the delay initially. But I hope that everybody enjoyed this and was like super tech kind of thing. I hope this was what you people were looking at or were looking for.
Thank you for the insightful presentation and the pleasure was out.
Thank you so much.
So everybody can find LinkedIn and also Gemma in the chat. So please.
Okay, so I think you have a very intermittent network because I could hear just like four or three or four words throughout.
So everybody,
So sorry, I cannot hear you. Okay, bye, everybody, and please, reach out and talk. If you have anything, just reach out to the DAX team or me directly. Hoping to speak with all of you, and thank you so much for being such a great host. Also to you, thank you so much. Thank you. Okay, so should we log off?
yes, I'm going to cut the meeting short and we will begin the next speech at 1.
Thank you.
Bye.
Bye bye.